Hey, what's up guys? Jake with Legacy 4x4 here again, and today I'm going to show you how I made all of the physical build of my new do-it-yourself industrial CNC plasma cutter. When we're all finished, it's going to look just like this, and I'm super excited to show you guys how I made this and what this end result's going to turn into here in a couple more videos. Be a good video again. It's going to be maybe a little bit longer, but I'm going to try to show more detail about how I put this table together. Today we are doing the frame and the mechanical portions of the table. As I was designing this table and figuring out how the best I wanted to do this to make this a much higher performance machine than the last one, I started looking at a lot of the turnkey systems you can buy from various manufacturers. One of which that I really liked the design of was Avid CNC, and I'm using, as you guys saw over there, I'm using a lot of Avid CNC parts. I'm making some design changes, like I don't want to make the whole thing out of aluminum extrusion because aluminum extrusion is expensive. So I'm choosing to use this steel here for a lot of like the legs and support structures, and I'm only using the aluminum extrusion for the drive axes of the machine, which you'll see in a second. But pretty straightforward. Like I said, I took a lot of design cues off of other turnkey machines, and I'm just mimicking stuff that I like, and I'm obviously doing it myself to save a little bit of money. The steel is also a lot cheaper than aluminum extrusion, so I did price out what it would cost to use all of the extruded aluminum on the whole build the way Avid CNC does, and it was very expensive. It was like $2,100 in aluminum alone. Instead, those three pieces there cost $480 shipped, and then I bought all of that steel there for another $400. So a total of $800 versus $2,100 in material. So that's why I went the direction I went. And you guys will see now this will require more fabrication, but it's gonna be worth it in the end as I keep the cost of this table, including the plasma cutter. The total cost of this table is gonna be below $5,000, which is what I was looking for. So without further ado, let's go and get started. We're gonna start with the rails here. I'm gonna put the linear blocks on it, and I'm gonna put the gear rails on it. And I'm doing that so that I can space out exactly how big I need to make my 2x2 frame structure to make sure everything lines up nice and tight. So I'm gonna go ahead and do those first, and then we'll get forward into kind of setting this up and figuring out how big we gotta make everything else. So let's go and get started, guys. Now the next step is to get some measurements and figure out how we're gonna do the base of this table. My general idea is I'm gonna do a square tube base plate around it with center support sections underneath of this aluminum. I'll have a piece of like 3/16 or something, or 1/8 jutting up from the edge of the square tube here that these are going to tap right into to secure these into place. The water table, which my steel supplier is currently making, will then slide right in here and rest on top of the 2x2 subframe I'm making. Relatively straightforward design. It's going to be pretty beefy and pretty sturdy when it's all finished, and it's going to provide a lot of rigidity to the system as a whole once I tap things all together. So this is what the two leg sides are going to look like. It's going to be what houses the Y axis of the machine. Obviously not finished yet. I've just got everything tacked into place. But you can see I just did this miter corner here just to make these nice and clean, and then I'll do cross support bars in the center to make this as wide as it needs to be. I also did the miter corner so that when I make this plate that this is going to mount into, I have more meat here on the tube to grab into than if I just use the open face of the tube. A little bit more flexibility in the design now. But you can see this isn't perfectly squared and leveled yet, but this is the way this is going to look. So there's going to be a plate that comes up here that's going to bolt into these two holes that I'm going to tap, and then the rail is going to run like so along the top of the legs I'm making. Pretty simple design. I'm going to go ahead and fully weld these into place, and then we'll get on to the next step. All right, making progress. I have the legs finished, the two of them. Now I'm going to make these center support cross beams. There's going to be a total of 4, 1 on each end and then 2 in the middle. And this is going to provide the structure that the water bed is going to sit on. So as you guys can see, this is the layout for the frame. It's pretty simple. You saw the legs already, and then it's just 4 horizontal pieces of tube in the middle there going across the length of the table, like, or the width of the table like that. Pretty simple. I'm using the ratchet straps to keep it all tight. I had it all, I just lined it up to square, double checked it, you know, doing the little cross thing. I'm gonna check it one more time before I weld, but that's the idea there. Steady progress. This is going by pretty quickly. I've only been at it for like 2 hours now, and I think I'm gonna knock this out today. I might do the caps on the legs today, and then we'll see. I'll finish it up tomorrow, but easy. All right, we made a ton of progress today. I'm pretty happy with where we're at. It's only been about 3-ish hours of work so far, and I've got, as you can see there, it's coming along really nicely actually. Let me go and give you guys a quick walk around where we're at now, and then I'll go through what we're gonna do tomorrow when I finish this up. So you can see on here, this is what the gantries look like. I just mocked them up there just for measurement sakes, just to make sure, but I have just enough room on the backside of each of these here because the linear rail and then the pillow block is gonna go out to right here, and then the gantry itself is gonna mount onto those, and then it's gonna tap into all of these holes up here on this beam, which should be plenty. There's 8 total holes on each side of this. That should be plenty to tap into. On this side, all of these smaller, the Y-axis rails, I'm gonna make a little plate right here that sits there with 2 holes drilled through it to tap into on each side, and that's what's gonna mount that face right there. That plate's also gonna have a little jut out to the side over here, and that little jut is going to be where I put my bump stop and my limit switches. You can see the basic design of the table. I think this is pretty sturdy, truthfully. I was jumping on it, standing on it. I don't see anything kind of come loose on this. I think this is gonna be plenty for what we're doing. All it has to do is support the water bed, and I think this is gonna work just fine for this. The water bed is gonna fit right in between these rails here. You wanna make sure that this is perfectly level and it's perfectly square as you build it. If you're out of square or if you're not level, you're gonna have issues later on when you get to the point of actually putting your table together. It's just things to keep in mind. Take your time with this kind of stuff, especially if this is your first build. It's better to do this right the first time and really take your time doing it. Day 2 of this build, guys. We're gonna go ahead and get started. I always buy a little bit overage when I buy steel because I keep whatever I have excess and I use it for other projects as things pop up. For example, I have this piece of about 2 feet of, this is about this is 1/4 inch by 4 inch piece of flat bar. I'm going to use this actually for my end caps. By doing it like this, I can just cut a 6-inch chunk of it, fit it right here, and it's gonna stick out 2 inches off to the side here, which gives me plenty of meat to bite into for my limit switch. But again, you could have used the 3-inch. The 3-inch would have worked just as well. You just would have been a little bit tighter. I had this laying around, so we're gonna use this. All right, so I'm gonna cut this to length. I'm just gonna cut 4 6-inch pieces of it on the slugger saw there, and then we're going to figure out how to make the holes for that, drill a bunch of holes, tap those ends, and then we're gonna see how this all fits up. All right, we're making pretty good progress. I'm gonna start to skip some stuff just to save you guys some time, kind of skip towards the actual more unique things that we're building. You can see I currently have the table upside down right now. I'm just gonna add in some cross supports here. I already added in a set on the horizontal portion of it. I'm just gonna do the long portion now. And I got the plates at the bottom there that are gonna be used to mount the gantry onto. So those are all finished up. So I'm gonna throw these crossbars in here, and then I'm gonna go down and I'm gonna smooth out all these welds down there, clean those up a little bit. And I gotta do one final weld over on that side, but easy progress. So you can see on that side, I've already got one installed. On this side, I just used that last little bit of 1/4 inch plate I had was actually exactly a 4-inch by 4-inch square, which was perfect to cut out 4 2-inch by 2-inch squares to use as the base point for the legs here. I drilled it out and then tapped it to 3/8 by 16ths, which is the thread on these casters off of Amazon. All right, so we're all finished up for today. I worked about 6 hours total on it today, so we're at a total of 9 hours so far on the build of this table, but here's what it looks like. The Y-axis gantries are in. They fit pretty snugly. This is the front of the table here, as labeled by my front. I snugged the gantries, the aluminum extrusion, up against these plates on both sides so that I know they're in the same place. All right, so in classic fashion, I found another mistake I'll share with you guys real quick. I'm gonna make it work, but it's still a mistake. I'll correct this on the bill of materials before I publish it for you guys. These, are heavy. These NEMA motors I'm using from OMC Stepper online have a 14mm shaft. This is a 1/2-inch hole. If you know the conversion factor, you'll know that 14mm is just barely too big. So this doesn't fit in this. Now, a solution moving forward, and what I'm going to show you guys, is I'm just going to pick a different motor, one that actually has a 1/2-inch shaft that will fit with these spindles from Avid CNC for the rack and pinion that we're using. However, because I don't want to wait for new motors to come in, and because these aren't very expensive, I'm going to just drill out this hole using a roughly 14mm drill bit and just make it bigger. So that's what we're about to do. It's not going to be perfect, but it'll work, and you know, it's close enough for this. I'll replace these eventually with different motors and with newer spindles when I get to it, but for now I just want to get this thing running. So you can see here, this is what one of the drives look like when they're all finished assembled. We've got the big NEMA 34 motor down here, and then we've got this gear reduction drive system here, and then this is the part of the gear that actually runs on the rack that's on the table. You can see I drilled out the hole on this like I just showed you guys, made it just slightly larger, and then there's set screws in there that are down there that pin it into place, and I evened it up as I was pinning it so that there's no wobble in it and it's all nice and tight. It doesn't look as clean anymore because there's some burr on the side of it and there's a little bend on the vise, but that's just cosmetic. I'm not too worried about it. The only thing that matters is the gear set in there, and none of that was affected. You can see on this side of it, it has a cam tensioning nut here with a tapped hole down there, and then the motor mounts straight into there, and there's a spot for the nuts to hold it into place. And then there's the gear reduction, and then this backside, this is how the drive will rotate in order to provide tension on the rack over there. And then there's one more piece that goes on this that you'll see a little bit later. Super clean though. These come like this from Avid CNC. These are machined aluminum. They've got tapped holes when they need to be tapped, and they go together extremely smoothly. I chose to go this route, even though it's $160 per drive, just to make this a super clean install and to really give some really high performance to this machine. But they fit any NEMA 24 or NEMA 23 or NEMA 34 motor, and they look super clean. They come with all the necessary bolts, nuts, cam tensioners, washers, everything you need to set one of these drives up and install it on the table over there. So anyways, I'm gonna drill out these last two, put these last two rack and pinion drives together. We're gonna weld in the electronics rail that's sitting right there, and then we're gonna make some progress. All right, steady progress. You can see kind of what this is shaping up to be like now. I've got almost all of the metal fabrication almost finished here. You can see what I've added. I'm doing an automatic drain system, which is gonna be its own video, but I picked up this 55-gallon plastic drum from somebody local for 20 bucks, and I just added down here, these are just two pieces of 2-inch by 2-inch angle iron, which go the full way across and are spread out just enough for the barrel to rest on. I'll latch the barrel down when I'm done to final assembly using 2 lashing straps. On this side over here, I did add this electronics rail. This is overkill, but I think it looks cleaner. This is just a piece of 4-inch channel. Like I said, this is way overkill for this application, but it's gonna give me a nice clean rail to run my electronics, like my cable management stuff, along. So my tracks are gonna go on this rail, and then somewhere back there-ish, we'll have the box. So I still need to design a mount for my electronics enclosure. It's gonna be somewhere on this side of the table. I just don't know how I wanna do that yet. And then I still need to make the cart for the Everlast. Then the Everlast will park itself right about this general area. These are what's gonna ride along the linear rail here. Those little riser assemblies are gonna mount to those pillow blocks there, and then they're gonna mount into the X-axis gantry here using these 8 holes that are on each side of the gantry. And then you can see this is what my gantry riser plate's shaping up to look like. I need to do a little bit of fine tuning still to it, clean it up, but it's making progress. I will have DXF files of these gantry hookups and the setups that I used if you wanted to mimic them, but they're pretty simple to make. The worst part is it's just a lot of drilling and tapping, but it's all pretty straightforward. But anyways, here's what these look like. So you can see this is the Y axis, A is over there, X is up top. This is the basic way that these work. So we have this riser plate, which is, I know, not smooth yet. I'm gonna smooth it out while the paint's drying on the rest of the frame. This is the drive assembly from Avid CNC, comes complete just like so. Hooks up very nicely, and I just drilled and tapped a 3/8 by 16 hole on the backside of it over here. All right. You can see that the drive system, I have a big cutout in the riser here, left for enough room to allow this to come and contact the rail as quickly or as smoothly as possible. I did leave this little half inch or this little inch up here and plenty of space on the back over there, so that as the gantry moves, the first thing that hits these end stops is not this drive system, it's actually the plate, the aluminum plate that's right here. There will be rubber on the backside of this as well. I've got some rubber bump stops to add, but just an extra layer of protection, giving it something to smack into first. The A-axis will be done exactly the same, as you can see, and it runs on 2 of these pillow block sliders there. The X-axis and the Z-axis are up here. They run on their own 2 linear rails here and here, with a total of 4 blocks behind them. I don't have this finished up yet. I'm gonna do this also while the paint's drying. I just wanted to get it painted today and put it back inside the garage so it can dry overnight. This is the basic idea though. I'm just gonna make an L with these 2 pieces of aluminum. I've already got some holes drilled here. I'll drill and tap holes into the side of this aluminum like so. And then that's what that's gonna mount to. If it's not strong enough, I will add additional steel brackets along it to strengthen this up as necessary. The X-axis works exactly the same way. Motor, gear rail, gear, and then there's a tension torsion thing that will be added as well. Pretty straightforward though. You can see how that looks, and now I've got plenty of space. My Z-axis will mount right here and allow the torch to go up and down as required. The whole thing is so much more steady and so much more controlled than my last one. I'm super excited to see this all the way through. So now what we're gonna do is I'm just gonna take everything apart. I'm gonna push this outside and we're gonna spray paint it black, like everything else in my garage, black and red. So we're gonna spray paint the frame black, and then we're gonna let that dry overnight, and we'll do final assembly tomorrow. This is it. We got it all finished up, or at least as far as we're going to go for this video today. I know the water table is not on the plasma cutter yet. That's going to be its own completely separate video because I'm doing an automatic plumbing, an automatic fill and drain system for it. So that's going to be its own video when I install the table and I install the plumbing for that. Anyways, this is what it looks like all finished up. Don't mind the mess in the garage. My wife and I are moving here in about a month, so things are a little bit messy, but you can see what the table looks like. We'll start from this side over here. This is the left-hand side as you look at the front of the table, and this is going to be the home of the electronics and all of the rail systems and everything else that the table has to operate. You can see in the back over there is the electronics enclosure that I was in the last video I just finished up. That bolts into a separate 2x2 frame that's over there, and then just bolts in using some angle iron supports. Pretty straightforward. What this does give is complete and easy access to all of the plugs for the motors and the limit switches, and then also for the CNC port and the Ethernet port down there. The wiring is going to run along this piece of channel iron that's here through the little rolling track things, just like what we used last time. That will go along with the table as it moves, like such. You can see all of the axes use a linear rail and a linear gear rack, like such. And then I'm using the Avid CNC rack and pinion drive here. That's the matching gear rail from Avid CNC to match their drive system that they've got here. My gantry risers are made out of 1/2 inch aluminum. If you do choose to mimic this design, I recommend going with 3/4 of an inch aluminum instead. Those Avid CNC parts are meant to work with 3/4 aluminum. So like you can see down here, I ended up just using some 2-inch wide, 1/2-inch diameter spacers here, just to spread that out to give it that last 1/4 of an inch. At each of the ends, these end caps hold these linear rails, the aluminum extrusion in place, and they also hold the rubber bump stops here that are pretty straightforward. There's just a bolt sent through the side here with a rubber bump stop there, like such, so that the gantry has something to hit on that's not just aluminum on steel. The limit switches will mount, and I haven't finished those yet, but I want to go ahead and get this video out. The limit switches will mount kind of here and back over here behind the motor down there to give the limits on the y-axis, and then on the x-axis that are going to mount actually right up front here on the top of the gantry. So that kind of covers the y-axis there. Pretty straightforward. All right, the x-axis, you can see same thing, except there's two linear rail bearings here to support motion there, so that way this is super sturdy and stable as it travels. Same gear rack, same drive system as the Y and A axes. The Z axis uses a eBay special. It's about $300. Is a plasma Z axis kit, which comes complete, all fully assembled and everything like that. You just have to screw in the plasma torch mounts and screw in your motor. It uses a 1/4-inch shaft motor, has a little coupler there to tie into the all thread rod they use there, and it does use linear bearing or linear rails as well to go up and down. This one includes 2 limit switches, a float switch, and a home switch. All right, so I hope you guys like that. It's pretty thorough again, so I know this video might have been a little bit on the long side, but that's fine. If you have any questions about some specifics, or you want any questions answered as you go through building your own table, be sure to drop them down below and I will get to them as soon as I can. So when I'm completely finished with the build, there will be a complete bill of materials list available on the Legacy 4x4 website. Total, this thing took me about 4 days to do at about 6 hours a day a piece, so roughly about 24 hours worth of work. Not a bad build, completely doable. Like I said, if you have any questions, feel free to drop them below and I'll answer them as best as I can. Like always, make sure to like, share, and subscribe, and take care, guys. We'll see you on the next one when we get onto the water table.